we are going to be working on chapter 8, which is rational functions. That is what we are going to work with today. Chapter 8, rational functions, day 1. I'm predicting we will need 2 days. It took me until chapter 8 to realize why my teacher notes are a little off from the PowerPoints. So we have PowerPoints that are split up by section, right? And then we also have the overarching chapter PowerPoints, which are supposed to be identical, you would think. They're from the same producer. What do you call that? What do you call a person that makes a book? Whatever. That
Publisher.
publishing company. Thank you. So they're from the same publishing company, but for some reason, the section PowerPoints and the whole chapter PowerPoints have just the smallest bit of a difference with some of the examples. So that's why when you're going through them, if you look at my teacher notes versus looking at the section PowerPoints, you'll go, hey, that's a little bit different. And I'm not going to lie, I also wanted to know, why is it a little bit different and why can't I just nicely follow this? Um, it's because it's between section and whole chapter, so whatever. The moral of that fun little antidote is if you're going to go through my chapter notes for this time, you want to reference the whole chapter. So the big one that says 157 slides instead of referencing the little ones. You can still reference the little ones for different examples. By all means, totally do that. Super worth it. Um, the other thing I want to let you know is instead of squeezing in all of my work on the teacher notes, I decided to do all of my scrap work on scratch paper, kind of like showing you what you should do. Um, but the reason for that is because I just didn't feel like squeezing it all in completely and making it totally unreadable. So you'll see the new teacher note, and then right behind it will be the scratch paper. So if you don't get the same answers as me, go to the scratch paper so you can see the steps. All right, enough random talk. Let's go through and do some problems, shall we? So for number 1, example 1, we are looking at evaluating a function, and the function we're given is f of x is equal to x minus 5 over x squared minus 4. So let me tell you that initially you might say, oh, x squared minus 4, let me go through and factor that. You can, totally up to you, kind of wasting your time because our questions here are not anything like put it in lowest terms. It literally just wants you to evaluate. So when you have to evaluate, you're just plugging the numbers in. And you should know that from chapters in the past. So you actually don't have to do anything but just plug in your numbers. So the first number we're going to plug in is 6. Second one we're going to do is -3. So if we plug 6 in, we'll get 6 minus 5 on top, which we should all know that one for sure. And then 6 squared minus 4 on the bottom. That ends up being 36 minus 4, so we get 32. Okay, so there is the first one. Now, if we were going to do that for the second one, just as easy, we're going to plug in -3 minus 5. And then in this case, if I were you guys, until you get super used to things, I would put the value in the negative in the parentheses so that you do not have to forget and drop off the negative or continue with the negative. So on top, we're going to get a -8. And then -3 squared is going to give us a +9. +9 minus 4 is going to give us a 5. So -8/5, right? Can you all see that if we would have factored the bottom, we would have just been wasting our time or I guess just practicing factoring, okay? So if you don't like the term wasting your time, you can call it practicing, but it's just really not necessary in this case. All right, let's move on to look at example 2. So example 2 is talking about finding the domain of a function. So let me ask you this. If we're thinking about the domain of a function, what are we after? Tell me what we're after. Domain is going to be talking about which variable?
Isn't it x?
Yes, it is the x. Okay, so we're wanting to know what your possible x values are. And now, most cases, when you're dealing with the linear families, it's going to be all real numbers all the time. Okay, but the problem is that you are now grown-ups. Okay, we're not working with just linear functions anymore. We're looking at all kinds of functions, and specifically for this chapter, you're working with rational functions. So rational functions can have a slew of different domains. And when we talk about rational functions, we are almost always talking about some form of a fraction. So because of that, we actually care about which part of the fraction when we're considering domain. So let me ask you this. 0 is a number, right? 0 is a very valid option for an answer choice for you, correct? When can you not have 0? When is 0 not allowed? When it is what? Boy, I give you guys a day off so you can do an exam that's due tomorrow, public service announcement. And then you guys all forget that I don't care if you mess up. Give me something. When can you not have a 0?
When it's in the denominator.
There you go, Lexi. And you weren't even wrong. You were right. Yes, when 0 is in the denominator, cannot happen, is not allowed. So for this specific problem, we don't care about the numerator so much. That could be literally anything. What we care about is when does x squared plus 5x plus 2 equal out to 0? That is what we care about. So looking at that, just kind of taking a guess at that, do you think we're going to be able to factor it, or do you think we're going to have to use a different approach?
Well, if it's not supposed to equal 0, you shouldn't factor it.
So you're correct. We don't want it to equal 0. So what we want to do is find out when does it equal 0. So then we can say our domain is all real numbers except in these two cases. Okay, so I'm going to let you know that this is a really gross problem. So we're not going to be able to factor it, but instead we can use what? When we have quadratics, we can easily think of what formula?
Quadratic formula.
Very good, the quadratic formula. And because we know that, even if it would have been a nice one, like you could have nicely factored, you can still use the quadratic formula. It is a very powerful, awesome tool that is now at your disposal any point in time. Okay, so there's our A, B, and C's. Let me get my handy dandy scratch paper. Okay, so we need to find out what x equals when we have these variable types. So we're going to bring our 5 out, and it's negative. So -5 plus or minus the square root of b squared, so 5 squared, minus 4 times a times c, all over 2 times a. So if we work that out, we end up getting, let me move you guys to the other side for a minute. We end up getting -5 plus or minus the square root of 17 all over 2. Now, you would think, oh, hey, great, I found my answer. You would be only a little bit incorrect. So what you guys need to say is something along the lines of my domain, so domain, which I tend to just use a capital D because we all know that math people don't really like words. And now you could write out the big long statement. I'm not going to. I'm just going to say all real numbers, all reals, except when x cannot equal -5 plus or minus the square root of 17 over 2. Now, I can tell you that this answer right here, this answer is a math answer. So that's the answer you want to use on your exam. Okay, so star it, exclamation point it, do whatever you have to do so that you know that is something that's important. That is something that Pearson does not understand. Okay, so the Pearson problems will not have you doing a statement like that. All right. Are we all good with this page? Are you okay if I clear it? Okay, cool. Just so you all know, I can lovingly scroll through and see all of your faces. So I do take all of you into consideration. I'm so nice, I know. All right, let's clear all of this. Okay. All right, so now we're gonna do part B of that example, which you're gonna find that you'll like it a little bit easier, which is amusing because initially it looks way grosser and you're gonna go, what? Why would we like this? I don't understand. That's okay. We're gonna go through it. All right, so on top you have x squared minus 5x plus 1. And then on the bottom, we have x squared plus 10. Right? And again, we are looking for the domain. We only care about the domain in this case. That's all the example wants us to talk about. So my question to you is, what's our denominator in this case?
Would it be the x squared plus 10?
Yes, it is the x squared plus 10. So the other question I have for you then is, if we have a denominator of x squared plus 10, let's go ahead and just write it out. We want to know when that denominator will be equal to 0. So we'll go ahead and subtract 10 on both sides. So x squared equals -10. Now, riddle me this one, Batman. Can an x squared be equal to a negative? Does that happen? Can you ever square an item and have it come out negative? No, you always get a positive. That means that no matter what you plug into this x, it is always going to be positive. So that means your answer is going to be all reals, no matter what. Now on Pearson, you'll probably do it like this, maybe, or if you do it like that and it doesn't like it, and you just can't really remember, let me know, and I will give it to you and override it. The other way they do it is they'll just write it out as a sentence, and sometimes even I forget about it. It'll say something like domain is all real numbers or solutions, and that's like your secondary answer choice. So if you're getting it wrong, no matter what you're doing, try hitting the other option. Just a Pearson hack for you. All right. Any questions on this type of problem? Any question on finding domains? Okay. You will do domains as you continue throughout your algebra journey, whether it's with me or another professor. You will have to find domains. You will be given functions either graphically or not graphically, and you'll have to do this, and that's okay because now you know how to do it. All right. Number 3, we are going to work with simplifying. Well, it would help if I could spell right. What's really sad is that the words are literally right in front of me. Okay, so that's the direction type they're giving us. Really, you're not gonna let me select that. There we go. Okay, so that is what we're working with right now. And let me get you the examples. So we have 3 of them. If anyone wants to be brave, you can let me know, and I don't have a problem sharing my screen at all. So 2x squared, and by sharing my screen, I mean letting you take it over. Okay. All right, so if you don't want to take over my screen, at least give me some ideas. We need to simplify the right-hand side. Obviously, I don't really know why they make that your direction set, because clearly the left-hand side just says f of x. How you want that to be more simplified, I don't know. So talk to me about it. How are we going to simplify our right-hand side? What ideas do you have? Go ahead, Mara.
I think I'd start by factoring out a 2 out of the entire equation.
Sure. We can pull a 2 out of the top, and we can also pull a 2 out of the bottom. I am going to do it separately just so that everyone can see. Everyone can see the common terms. Okay. Oops. Don't forget that, like I did. Kind of makes a difference for you. Okay. So we were able to pull out a 2 on the top and bottom, so we know that that's going to end up canceling. But before we cancel, what else can we do? What else can we pull out? I guess a better term is, what else can we factor?
An x minus 5 and an x plus 2 for the top one.
Yes. Okay, anybody get the bottom?
It's the same.
It's identically the same. We're gonna have a sign difference, right?
No, it's a x minus 5, x plus 5.
There you go. Nice. So now we can go through and cancel out. Perfect. I'm gonna use a different color. And just so you guys know, I use different colors on my scratch paper too, probably because I have some ADHD or something inside me. So if you can't read it, just let me know. I'll try to be more boring and just use regular colors, but I don't really like to. Okay. So x plus 2, x plus 5 is your overall answer because that is the only stuff that is left. Now, if we were doing a complete problem and bringing everything together, what domain would this problem have? What x value cannot go into this problem?
It would be all real numbers except for -5.
Right, x cannot equal -5. All right. And I'm not saying that you have to do that for every single homework problem, but if you wanted to practice some of that, you totally can. There's nothing stopping you. I'm completely fine if you want to practice some things. Oh no, don't move like that. Okay. All right. So let's move on to B. And B is,
Wait.
what's up?
Oh, okay, never mind. I couldn't see the screen.
Because I need you to be able to see the screen. All right, so B is x squared minus x minus 12 all over 4 minus x.
Forgot my tea in the car.
Okay. So I do apologize, guys. I am teaching at a public space, kind of. I'm at Sylvan because I have sessions later today. And for some reason, the gentlemen who apparently work upstairs think it's totally fine to just laugh very boisterously in the hallway without really sharing what they're laughing about. I probably wouldn't feel the same way anyway. All right, so x squared minus x minus 12. That should kind of be screaming, hey, I think you should factor me at you. Okay, so let's go ahead and start there. And then you'll see that we are going to end up doing something with the bottom. Might be a little bit different than what you would potentially think to do. So it's a little bit of a trick that we like to use. So, all right, if we're factoring the top, what are we going to do? Can be anyone. Not just my all-stars on the first and second pages. So the first step when we factor, which now you're starting to see why we did a whole chapter on factoring, right? Everything builds, everything comes together. So the first step for factoring is we're going to split it up, x and x, right? And we need a factor of -12 that is going to add or subtract to give us a -1 in the middle. So what's that going to be?
-4 and +3.
There it is. Okay, so we'll stick with the +3 and -4. Now let me ask you something before we move on. That x minus 4, what does it kind of look like to you? What are you guys going to want to do with that x minus 4, but you can't really yet?
It looks similar to the denominator, but the signs are switched.
Right. So since the signs are switched, we're going to do a little math trickery here. And I call it that because sometimes students go, wait, why can we do that? And I can answer you why we can do that, but hopefully you can also answer me why we can do that. So I just pulled out a factor of a -1, and I'm allowed to do that because there's nothing saying I can't do that, right? So now it looks nice enough that you can go through and you can actually cancel out your x minus 4s. And the only thing that means is that you have to have a negative out front. Now you can leave it as a negative sign out front and then the quantity x plus 3, or you can go ahead and you can distribute that negative and make it negative x minus 3. You can do either. Pearson, I believe, takes either. If for some reason you put a similar problem in and Pearson goes, you haven't simplified yet, then you know that you can go through and just simplify it. But it should take an equivalent answer like that. If it doesn't and you don't understand why, just feel free to email me and we can go through it. Okay. Also, because this is like the third time that I'm rewriting these problems, and make sure that if you guys think, oh, hey, we'd be able to factor if this was just this number, just make sure that I'm writing it correctly. If you're asking that question, I probably have a typo. All right, so let's look at what we can do here. I'm going to go ahead and give you guys the hint that we're going to have to go through and factor everything. But I want you guys to take a few seconds and try to do it with. I do want us to note one thing up here. This is actually going to be plus or minus 5. And here's why. We have to look at the original denominator. See how the original denominator has a square in it? Okay, so you have to go with what that original denominator would give you. Just wanted you guys to have that information. All right. Anybody have anything for us?
Would one of the numbers be a -4?
Are you talking to me about the top or the bottom?
The top.
Yeah. So we are going to actually have a negative for what? What has to go with the -4s?
Why?
Yes. Very good. So we have a y here and a y here. And then we know that in the front is just the x's. Okay, so that's the top one factor. Very good. Great teamwork. All right. The bottom is going to be pretty similar. We're going to use the x's first, of course. Then we'll have opposite signs. One will be positive, one will be negative. And then we're going to do the same thing, 4y and 4y. Okay. Can we get rid of anything? Does anything cancel out? Yes. So I'm going to cancel out this one and this one. And that is going to leave us with x minus 4y over x plus 4y. Okay. Now, I will tell you that understanding examples 2 and 3 are extremely important, because as we move on in this chapter, you're going to see that we're going to continuously do things like this, but then they'll have more meaning behind it, okay? So we like I said, we're constantly building. All right. Right. Any questions up to this point? I know we've only done 3 examples, but there's been a lot of problems. So I want to make sure that you guys are solid. All right. We do have, I am saving all of these, and I do have all of my stuff equally. So I'm going to need to put that up online for you. I will do that after my second class today. Okay, so for example number 4, we want to actually create our functions. Okay, so we are given f of x equals 8x cubed minus 125. What should that be screaming at you?
Factor.
Yes, specifically a factoring of 2 perfect cubes. 4x squared minus 25. Okay, so for part A, they want us to find the equation for f over g. And then once we do that, for part B, they just want us to do an evaluation of f over g at 3. Okay, so what do you think your first step should be here? How would you guys go about solving this problem if I wasn't here?
Would we factor them first?
So I would factor them first, because I think that's a great idea. And then just as long as you remember what piece is what, then you're cool to go. If not, you can feel free to write them out and then factor. I think for the sake of the recording, I'll go ahead and fill them in, and then we can factor them. So we're going to put f on top. But absolutely, if you guys are on point with Blaine, feel free to factor first and then put your pieces where they belong. So, all right, so for the top, we know that that's a difference of 2 perfect cubes, which means we can go ahead and factor out 2x minus 5. And then we would have 4x squared plus 10x plus 25. And if you forget how we did that, feel free to go back into your notes or into our videos and watch the section about perfect cubes. Okay. All right, to do the next one, now typically we could try to factor something else out, but we're actually just going to leave them be, because we can do 2x minus 5 and 2x plus 5, and you can see that's actually going to be really nice for us, because what happens?
You cancel out.
yeah, those first sets cancel out. Okay. So if you wanted to write it a little bit neater, you can, but this is actually your whole first answer. You just added it. So I guess if we want to be neat, I can rewrite it. F over G is just 4x squared plus 10x plus 25 over 2x plus 5. And now to do part B, we just have to throw it in. Okay, we're just going to put a 3 in for each of the x's. 4, 3 squared plus 10 times 3 plus 25 all over 2 times 3 plus 5. And if you work that out, you end up getting 91 over 11. For the exam, if you want to give me a decimal, that's fine. I try very hard on my answer keys to try to remember to give both the fraction and the decimal. I will never take off points if you have an equivalent decimal answer. So please keep that in mind. But I typically tend to do my own answers in fractions. I just kind of like them better than decimals. I know I'm probably a little bit weird. But then I think I also like it because it means I went through and did the work and didn't have a calculator spit it out at me. So I don't really care, just make sure that it's equivalent. Because if it's not equivalent and I didn't see that you just easily had a rounding issue or chose to round, then I probably would take some points off. And I don't really want to do that. So fractions, probably the better way to go. All right, any questions on this example? Okay, because we are going to go over into the, we're going to go over into the PowerPoint, or I'm going to try to. Why is it not letting me share the PowerPoint? Maybe I'll just take it off the second screen. Maybe it's being confused. Okay, now can you guys see the PowerPoint? Yes, great. Apparently it was just confused having it opened on 2 tabs. It was not happy about it. All right, so we're going to go over example 5. It starts on slide 31. All right, so this is why I wanted you guys to see the whole problem instead of me just going through on the board. So as you can see, we're going to be dealing with one of our lovely application-based problems that so many students just thoroughly love and enjoy. And I do apologize because in the beginning, Mackie had asked, where was I getting some of my information? And my brain had just completely forgotten that these PowerPoints exist. So now we can have, it rock on. All right. So here's what our application problem is for this chapter. We are talking about internet users. And the reason why I find this problem so highly amusing right now is because in both examples, both in the smaller section 8.1 by itself, and in this one, we're talking about internet usage and the millions of internet users in America specifically. And in both questions, one deals with 2015 and the other deals with 2018. And I find it so amusing because now in 2020, it would just, this whole problem would just be destroyed. It would be like internet users in America. everyone? What's the number choice for everyone? So I just find it highly amusing. So, all right, what you would want to do with this problem is first you have to kind of decide what is Pearson giving you. So, or what are you being given in general? This is the kind of problem that ideally in the real world, you would be collecting and gathering this data, okay? If any of you are signed up or would like to sign up for Math 150, this is what we do the whole time, okay? I love teaching the Math 150. I love doing the probability and stats because even though it has a slew of homework that you have to deal with, I sometimes go in and delete them because I'm like, this is too much homework. This is so much. I'm having anxiety. I'm not even taking the class, I'm teaching it. So I go in and I get rid of some of that homework. But aside from the homework, I try to make stats as hands-on as humanly possible. So that is my little plug that I think you should all take stats and probability if you can. If not, hey, whatever, hopefully take me for another class anyway. So if you wanted to find out how they got this 8.8T and this positive 150.4, that's going back to, remember when we did our linear regression and we put in our L1 and our L2? This is our L1 and our L2. They just kind of did some of the work for you, okay? I'm not sure if Pearson will be that nice. So just kind of jot down, hey, this is my L1 and L2 in case Pearson decides that they aren't going to be as nice as their slide is. So what we could care about for part A, we want to find P of T. So basically we're finding the equation. For B, we're going to use the equation and we're going to find it for 2010. Now, if our initial start time is 2000, what would we plug in as our T if we care about 2010?
10.
Perfect. Okay. And then for the last part, we're going to find out P of 18. All right, so we're just plugging things in. That's really how simple this process is when they give you everything. When they don't give you everything, then you guys we all get confused sometimes. Okay, go ahead and fill this out. If you prefer, you can always wait until the recording and you can fill it out then. Totally up to you how you want to decide to do that. Like I said, for the case of the problem itself, all they really care about is this last portion. Oh, that's right. I can write on this, right? Yes. So all they care about is this section right here for your answer. Okay. If you have any questions, please ask them now, as I will not be with you if you watch the video. All they did here really from step 1 to step 2 is they brought in the 100 and they chose to bring it in on the top. That's probably the best place for it to go. I would not do it any other way. The only additional thing you could have done with this problem is instead of bringing in the 100, you could have decided to go ahead and find your answer and then at the very end multiplied by 100. But because they're bringing in the 100 in the beginning, it is very, very important that you all realize that the answer you are going to get out is already a percentage. So do not multiply it by 100 again and then get really confused as to why you're getting such a large percentage, okay? So definitely if you take this approach, the percentage is already going to be given, right? Let me know if you need a little bit more time with this. I know with the PowerPoint, I can go a little bit faster and I want to make sure you all have enough time. Excuse me. To hit resume recording. Sorry. Thankfully we didn't just record only 2 seconds. Like I did the one factoring day. We do have the entirety recorded. But anyway, as I was saying, so you're gonna plug in T, 10 for T. You're gonna go through, you'll find that they rounded. The important part when you're talking about application-based problems is you can't just say, oh, the answer's, about 78%. You want to give someone who say isn't me and doesn't understand what you're trying to relay. You want to give them almost a little bit of a story. And I know that I say a lot of times, I jokingly say that math people don't care about words. That's true like 90% of the time. When we're talking about an application-based problem, you actually kind of have to give me some words. Now, you don't have to give me every single word they used here. You can just go with the first sentence. The model indicates that we have about 78% of Americans who were using the internet in 2010. And you don't have to do it verbatim either. You can make your own sentence up. Then the other important sentence that I will tell you about is down here where it says our result using the model is a slight estimate or overestimate. That's also important. But what you really want to take away from this slide is that you want to give a little bit of a story when it's an application-based problem. The second thing to take away from this is notice that it wants you to describe your error per se, because it wants you to look at what they give you in the table. So if we go back to the table, here's 2010, and then here's the internet users in millions. Okay, so you have to remember that they're in millions, for one. And for two, this is actual data. So that means that they didn't just plug their 6, 7, 8, 9, and 10 in, they actually compiled that data. So it's going to give you a slightly different answer than if you plug in what you should get based on your model. And that's what they did here, okay? This part, okay? That's what they're doing there. They're actually plugging in from the model, all right? So make sure that you take that key point away. All right. And if I go too fast, just make sure that you watch the video and you can pause it where you need to pause it at. All right. Part C, you had to plug in 18, and then it wanted you to tell a sentence about what it meant. Well, 18 would be what year? If it's 18 years after 2000, yeah.
2018.
Good, it's 2018. So, and again, this is kind of like your prediction, okay? It's based on the model. They could end up running the numbers and you could end up finding that it's going to be a little bit higher, a little bit lower, whatever the situation might be. That doesn't mean that this model is wrong. It's actually a really, really good model because you are so close to the actual numbers. And like I said, no matter what happens, whether it's this problem or another problem, any problem dealing with 2020 or the eventuality of 2020 is going to be massively just blown up because 2020 was not predicted anywhere, okay? And especially with internet usage. Okay, so we're gonna talk about rational expressions, and something that I want you guys to keep in mind. I think we can go back to the whiteboard for a moment, but before I do that, let me just have you guys write this slide down. Where's it at? We're going to go back through these problems. Don't feel like we're not going to get to them, but eventually we're going to get to this. Here we go. go ahead and write this down. Spend the time and do it now. Nope, that's not the one I wanted you to review yet. I do want you to write this one down. Just give me 1 second because I want to make sure. Yeah, I don't really care about that one. I lied. We're just going to do the problems. So this is the one I care about. I'm going to scratch the other one out. Or you guys can just review it on your own. Okay, so I definitely would suggest, unless you're by chance some of the few people watching on YouTube that aren't one of my students, I would suggest going through the PowerPoint, which you can obviously find on Canvas. So eventually we're going to get to problems where we're doing this. It may not be too what have we done? 1241? Or is it 1246? This is weird. It's always weird, right? We always have a weird time ending. So if you know these, or if you just want to take a picture of it, you can snap a picture of it on your phone too. However you guys want to do that. You can write them out, obviously. Notice that the parts where they have the approximations, those are approximations because there's some fluctuation there based on the equivalent fractions. And obviously you have to keep in mind that for a year we go with 365, but every 4 years we of course have 366 because of leap year. So that's why there are approximations. And these decimals are just kind of what the convention is, which means typically everyone all over the world is going to be using the same decimals, okay? It's been agreed upon, all right? If you really wanted a better approach, you should use the fractions, but I'm not going to go through and figure those out. All right, any questions with the units? And we are going to go through some of those problems, but I just want us to go back into the whiteboard for some of them. Oh, that's so cool. I just hit the save button to see if I could save just this screen, and I totally could. I think that's super neat. All right. So I will make sure that I pull this slide out specifically. So if you guys don't get all of it at this moment in time, that's okay. Like I said, I don't even know if we're gonna get to it, but I just wanted you guys to be able to write it down so that we can go back into the whiteboard. All right, so let's switch gears and get you back into the whiteboard. Maybe if, okay. All right, so we are going to now look at example 6, which is to find the product and simplify the result. So the problem they're giving us is 4x cubed over 7x minus 1 times 3x plus 5 over 2x. I will tell you that this problem is pretty easy. Now, the way the PowerPoint goes through and how you do it, it literally makes you pull out every single factoring for all of it. So you'll have like basically little factoring trees in each spot. I don't do that. This is my question for you. Can you see anything that you can easily factor? As in either factor or cancel out? So keep in mind with fractions, you can cancel either up and down or you can cancel diagonal. Okay, the only way you can't cancel is across. So what do you guys think you can see?
Is it something with 4x cubed and 2x?
Mm-hmm. Yep, we can actually get rid of the 2x in entirety. And we're going to be left up here with a 2x squared. And now all we have to do is bring that together. So we'll have 2x squared on the outside, 3x plus 5, all over your 7x minus 1. And that's it. I do not recommend expanding. So I would not go through and do the distribution on the top. However, like I said, I think Pearson will accept either. But as far as I'm concerned, I would just go through and I would just stop there. And actually, I am going to get us a new page when you guys are ready. So just let me know when I can delete this. Also, another short public service announcement. Your midterm grades are going to be due tomorrow by 8 p.m. I will probably try to put them in today. I can tell you that you probably will not be surprised by them. They're basically in Pearson for you already. So, yeah. If you are surprised, make sure you get a hold of me so we can figure out what you need to do to get back on track. All right, let's move on to example 7. Okay, so for example 7, we want to find what's called a product function. So the first thing they give us is f of x. F of x is equal to 35x squared minus 25x over x squared minus 36. And then g of x, would it help you guys if I do it in a different color? I guess I can do it in a different color. I like that anyway. Okay, so g of x is given to us as 6 minus x over 15x to the 4th. All right, so then they want us to find, first they want us to find f times g. And then after that, they'll want us to do f times g and evaluate it at 2. Okay, so let's take the first step of figuring out f of x. Can we go through and factor anything out for f of x? Can that be broken down at all? What can we pull out of the top?
A 5x.
Perfect. So we're going to pull a 5x out. And we're going to have a 7x minus 5 left inside. And then the bottom is going to end up being x plus 6 and x minus 6. Okay. And then we're going to multiply it by g of x. So the bottom will be 15x to the 4th. Now I am going to pull out my -1 so that you guys can see the cancellations. So what can we cancel?
The x minus 6's.
X minus 6's. And then if you notice, we can actually also cancel the 5x with the 15x plus 4. And we're going to end up with a 3x cubed. Okay, so if we bring everything together now, we end up with a negative 7x minus 5 over 3x cubed x plus 6. Okay, now again, I do not recommend expanding it. And for as far as the actual function, that's probably what they're looking for. If you wanted to go through and expand it, you can. I think Pearson would still accept it. I would accept it, obviously, because it would be equivalent. But that is kind of neat enough. You don't have to go through and do anything else. That's kind of where we like to keep things. All right. And then now, if we want to do the second part where it's just the f of g being evaluated at 2, we're just going to plug 2 in for all of our x's. So -7 times 2. And then we can go through and distribute the negative now. So that'll be a plus 5. And then 3 times 2 cubed times 2 plus 6. So if you go through and simplify it, you'll end up with -9 over 192. And then that ends up simplifying again to -3 over 64. Again, you could choose to give the decimal version. I don't feel it's necessary, but if that's what you like, then go for it. The next thing we want to find is the quotient function. So it's pretty similar. What can you guys remember about fractions and quotients, though? I think we're almost done. We'll probably stop after example 9. That will grab.
On the slide.
Oh, nope, I'm skipping one. So we're going to do example 8 and then example 9. So example 8 is pretty easy. They want you to find the quotient. and they give you 6x squared over x minus 3 divided by 4x to the 7th over x plus 1. What can you guys tell me, or what can you guys recall about that? By a fraction? What do we end up doing?
Multiplying by the reciprocal.
Perfect. Thank you. So we're going to leave our first one alone, 6x squared over x minus 3. And of course, you guys know this is just a simple example because we don't even have to fraction. Wow. We don't have to factor with this one. Okay. So the only part here that we can go through and simplify will be the coefficients and the variables. Okay. So 6 and 4 both share a 2. So we'll end up with 3 on top. The squared goes away because x to the 7th is bigger. So 2x to the 5th on the bottom.
Push that. What the fuck?
Whoa. All right. And then we're just going to bring it together. So 3x plus 1 over 2x to the 5th x minus 3. And that's that one. P.S. I love teaching college students, and that's why I say my videos are never made for children. Because you never know when I'm going to do something.
I didn't realize it was not muted.
That's all right. I almost muted you before, but I was like, nah, you're doing all right. My B. All right. So, oh, I wish we could end on that awesome note, but I still have one more problem. All right. Anyone have any questions on this approach? That made my morning, so don't even feel bad. Oh, it's not even morning anymore. It's afternoon, but oh, that's my life. I'm so happy with it. All right, example 9. Like I said, super close to what example 7 was, except now we're looking for the quotient function. Wow, it's so hard to say sometimes. So, all right, we're given f of x equal to 81x squared minus 49 over 3x squared plus 16x plus 5. And then I'll use a different color for you guys. So g of x. Somehow g of x always ends up being green. I'm sorry, don't know why. 7 minus 9x over 18x plus 6. All right. Now, again, you guys could go through and you can decide to go ahead and factor first. But I'm going to warn you that because we're dealing with fractions and you're going to end up having to flip the second one and multiply by the reciprocal, I just don't want anyone to get confused. So you can choose to do it however you want, but if you find out that you're making some mistakes, that could be where your mistake is being made. All right, so let's go ahead and just write it out for normal for them without taking any skipping steps. And then if you guys want to try and skip steps on your own with homework problems, more power to you. Now, we will be dividing, but in a second, we're going to end up doing the rest of our process. So minus 9x over 18x plus 6. So again, we're going to multiply and flip that second part of the fraction. But before we do that, let's do some factoring here now. We're going to have our factors for this part. It is going to be flipped. So I hope you guys out with the bottom one. It ends up being 3x plus 1 and then x plus 5. Right. Then on the top, we actually end up getting 9x minus 7 and 9x plus 7. All right. And then we're going to go through and we're going to flip that second one. All right. But what do you notice? When we flip this, we can actually flip and factor at the same time. What can we pull out of that 7 minus 9x that's going to help us? What do we want to pull out of that?
-1.
There you go. So we're going to pull that -1 out. We're going to end up with 9x minus 7. And we're going to be able to cancel that guy out. And then the 18x plus 6, when we move it to the top, what can we factor out there? What's common in both 18 and 6?
6.
Very good. So we're going to pull that 6 out. We're going to end up getting 3x plus 1. And that is also going to be able to be canceled. So 3x plus 1s. And then our 9x minus 7s. They are gone, which means when we bring this together, we get 6 on the outside, 9x plus 7 over x plus 5. But we have that negative. Okay, so there you go. The only thing we have left to do now is we're going to plug a 3 in here. So if we wanted to find f over g of 3, we're now going to plug a 3 in for each of these pieces. So 9 times 3 plus 7 over negative 3 plus 5. So if you work that out, you end up getting negative 204 over 8, which works out again to negative 51 over 2. Okay. I believe I forgot to save something. Reach out, writing your notes, and then I'll put everything up together. Everything is as normal. Everything is up on